G'day. It's great to be out in my Scamp camper. At the moment I'm up in Tobyhanna Park in Pennsylvania. I've set up most of the things I need to go for camping, but one thing I'm missing is a AI host in my camper. I'd like to be able to connect to AI systems even when I don't have a network connection, kind of like at the moment. I haven't got a very good connection. As well, I want the AI system to be configured to provide useful information about my Scamp camper, as well as camping in general. Things like what local parks there are, what RV facilities are there, and so I can use it to plan where I'm going to go to next. And I also want to be private, so any information I give the AI doesn't go across the internet, but just stays local. So this has driven a project to learn more about AI and all the various AI frameworks, things like LLMs and supporting hardware and software. So in this series of videos, I want to be using things like Ollama, Open-Webui, an NVIDIA Jetson Nano, and a Raspberry Pi. I'm going to use things like LangChain, some RAG to get the information I want about camping and things, and try out various small LLMs. I want to put all this together in a small box. I'm calling it my AI Datacenter in my Scamp. That will fit under the seat here that I'm sitting on at the moment. And it's got to support all the normal constraints of camping, so not having a lot of power, so it can't be a huge wattage NVIDIA graphics card or anything like that. And it's got to be pretty rugged, because as it travels around it's going to get bounced quite a bit. Okay, so I've spent 2 or 3 months on this, planning what I was going to do. Among other things, I wanted to use a NVIDIA Jetson Nano development board to do the AI stuff, and that actually took 3 or 4 months to order and arrive as well. They seem to be very backlogged on those. But the components of this is, let's start from the power supply. So I've got 12 volts coming into the device, and I've got a 12 volt to 5 volt converter here. So the 12 volts is used by the Jetson Nano. It actually has its own circuitry for reducing that to the voltage it uses on the board. And otherwise the 5 volts out of this converter, and it's fairly beefy, it's 15 amp converter. At the moment I use for powering an Ethernet switch here, 1 into 3 Ethernet switch, and the Raspberry Pi. This is a Raspberry Pi 4, and I've also installed a SSD on it to get the best performance possible out of it. Same thing for the Jetson Nano, it's got an SSD on it to improve the performance. What I'm doing here is on the Jetson Nano, that's really well set up for running an LLM, or at least a small LLM, so something like a 3 billion parameter model fits on it pretty well. And also I'm going to run Ollama on it, which is the thing for hosting the LLM. That's about all I want to run on the Jetson Nano, and it leaves as much memory free for it to do its LLM stuff. So any other sort of processing, I thought I'd move up to the Raspberry Pi. So at the moment I'm just running Open-Webui on that, and I'll give you an example of that. And I'm also going to host various knowledge bases on there, things like camp information, information about the Scamp camper, about how to fix it and things, general camping knowledge. And I'm going to run some sort of RAG system. It may actually be using MCP to get the knowledge, but that's still to be worked out. But generally I know I'm going to be running sort of processing intense applications on the Raspberry Pi, and then leave the Jetson Nano just for doing the LLM thing. And most of that, what the LLMs will be doing, will not be using their own knowledge, but be doing things like interpreting language, working out what knowledge is needed, those sort of things. But then leave more of the straightforward processing to happen on the Raspberry Pi. Those two are going to be connected through the switch here, through the internal Ethernet adapters to get the best performance as possible between them. So that's like a 1 gig network there, should be fast enough. And I'm also going to have an outlet on the box that I'm putting on this to connect up to the internet as well. Okay, let's have a closer look at the Jetson Ollama Nano side of things. So why am I using Jetson Nano for AI? I think it's one of the best small development boards for running AI. There's a lot of YouTube videos out there showing people using it and what sort of performance they're getting. But because it's specifically made for AI and graphics, it can do a lot better than something like a Raspberry Pi to run AI. It just has a lot more memory and processing power to do the AI side of things. So just a summary what Jetson Ollama Nano is. Again, there's a lot of good links out on the internet about detail of how you use it. But it's a small development board. There's kind of a rundown on what it is, but the highlights is the highlights. So has capability of delivering 67 TOPS or trillion operations per second. So you need a lot of small, fast operations that you can only get with very parallel architectures, and the Jetson Nano does that. Got very fast memory bandwidth, especially for a development board. And if we run down to the bottom here, shows you the amount of memory. There's like 8 gig of memory available for running models, so you can get some larger small language models installed and run. It doesn't have to be the absolute smallest models that you run, so there's a bit more capability there. And then the other thing is that it power usage, it can use up to 25 watts, but again, that's very small power usage for AI. And again, to get this running in my Scamp when I'm camping and may not be connected into mains power, 25 watts is still doable. It's, you know, at 12 volts, that's probably a couple of amps of power draw, and that's doable with kind of the power that I've got in my Scamp. Okay, a quick look at how I set up the Jetson Nano. I won't go into details. Again, there's lots of good YouTube videos about how to do that, and I'll put some of the links in the description below. But first you need a NVIDIA developer account, so you can just sign on, get a free account. And under that I go to the embedded Jetpack page, and again I'll put the link down below for that. And what you want to do is download the SD card image for the Jetson Ollama Nano developer kit. So download that, then put it onto an SD card. You probably need one. I think I went with about 120 gig of room on it. And then you can plug that into your Jetson Nano, just like a Raspberry Pi, fire it up. And if you have a monitor and a keyboard attached and a network attached, you can go through the install process and set up an account and things. So that's how you get the initial Ollama Nano running. But I also wanted to have a SSD being used rather than a SD, just to get the faster performance of that and a lot more room on the machine. So what I ended up doing is went with the description by Jetson Hacks of how to install a SSD onto the development board. This is the video here. I have the link down below. And the nice thing about this one is you don't need an external Linux machine to set up the SSD. You can just do it all by installing the hardware, the physical SSD. You can kind of see it there. And then just running a script that he's created that copies everything that's on the SD card onto the SSD, and it'll fire up and it'll be in the same state as your SD, so it'll have your account set up and everything already, so it'll be ready to go with the Jetson after that. Run the large language models on the Jetson Nano. I'm going to use a service called Ollama, again lots of references to it out on the internet. And I'm going to be running it on the Jetson, so it's going to be running in Linux. So the way you install that, and I'll show you installing it, is use this curl command. And after you've signed into your Jetson, run the curl command. I've actually run it, so this is just going to update Ollama rather than do a new install. So this downloads the latest version of Ollama, installs all the dependencies, and also sets up a systemd service to have it running in the background. Okay, from another machine, I'm just going to see whether I can reach that Ollama service on the Jetson. And you see it couldn't reach it across the network, so we need to make a change to the service to make sure Ollama on the Jetson can receive network traffic from other machines. So what I'm going to do, so I'm back on the Jetson, is I'm going to use Nano as an editor to edit the ollama.service file. And there we see the service file. So I had to do that as sudo because this is a protected file. And what I'm going to add to the service environment settings is this Ollama host setting, and just say it's going to be open to data coming in from anywhere on the network. You can change that if you want. But basically the 0.0.0.0 is saying receive any network traffic. Let's save that away. Now I'm going to restart the systemd services. So first we need to do that. Then we'll do a restart on the actual Ollama service. So that new environment parameter should be taken. Now if I go over to another machine and rerun the curl command, this time it tells me Ollama is running, so it's been able to work with requests coming in across the network. And I'm doing this because I want to just run Ollama on the Jetson, nothing else, to give as much memory available for Ollama and the large language models, and not have anything else running on the Jetson. So I'm generally running the Jetson headless and nothing other than Ollama sort of running as a service. Okay, just to show you Ollama running on the Jetson, I've actually split the session tab here, so I've got two Jetson sessions running. So over on this side, I've actually done an install of a thing called btop, so you can just do a sudo apt install btop. So I'm going to run that, and I find that's kind of the best way of watching what's happening on the Jetson. As far as this area here is kind of the one I'm looking for, is amount of memory used, and CPU usage up here. And over here I'm going to run some Ollama commands. So one useful command is Ollama list, and I've already pulled down 3 or 4 models. The ones I'm going to have a look at this is the Llama 3.2 latest model, so that uses up about 2 gig of memory. And a larger model is this one here, this Gemma 3 4B model, which uses 3.3 gigabits. So let's try running the first model, this one here, Llama 3.2. So I'm going to run it with this command and be in verbose mode so I can see how fast it's running. So if I run it over here on the monitor, we should see the memory get used up as the Llama model gets loaded into memory. There we see. So I've used 4.24 gigabytes now. And let's just test this out with a high. And the interesting thing here is the evaluation rate. So I'm getting about 14 tokens per second, which is kind of about the most useful low as you want to go with tokens per second. But you can see here the CPU ramped up when I was actually evaluating the high command. And do other things like how are you? So a little bit more complicated. See a higher evaluation rate, 16.73 in that case. So we're good with that. So let me break out of that model. And this time I'm going to run a larger model. This one here, this Gemma. So let's go down here, update our command to run this model. Run it in verbose mode again. If I run this, so it's actually going to take the old model out of memory and then load up the Gemma 3 model, which is a larger model, so it's going to use up most of the memory. And the thing I'm looking for when I'm running these models is make sure it all fits in memory, make sure there's not a lot of swap happening or no swapping at all happening. So I may still have to do a bit of tuning with this one, but that one's loaded in now. Let's try the same thing, do a high. And this time we're going to be about 10 tokens per second. Same thing, how are you? And still about 10 tokens per second, so that's probably usable. So that's about as big a model as I was probably going to run on a NVIDIA Jetson, and we see we've used 71% of the memory to run that, which sounds about right for probably a 4 gig model. So let's have a look at the Raspberry Pi. So this is going to be running everything other than the LLM and Ollama. So the main thing it's going to be running at the moment is Open-Webui, which is an interface to Ollama, but it's also going to be running knowledge bases that I'm going to use to get more information for my LLM. And to run all that, I'll probably be running it on Docker, so I'll need to install Docker as well. Let's have a look at that. So for the hardware side of thing, basically I started with a Raspberry Pi 5 as a 4 gigabyte model. I had one of these hanging around, the main reason why I used that. And I used Raspberry Pi OS Lite version, 64-bit, so I could run it headless as well. Again, I want to keep overhead down. And to that, I went and installed a Pi Moroni NVMe hat. So that's where I ran the SSD. And the SSD allows the Raspberry Pi to run faster. Usually has a lot more space on it than a SSD, and it's more reliable. So onto the Raspberry Pi. First I wanted to install Docker. You can see the command I used here. If you go up to the Docker site for Linux installs, that's where the command comes from. But basically uses curl to install the things it needs to get Docker onto the Raspberry Pi. Once I got that installed, I also wanted to set up Portainer. So this is a way of giving you a GUI to look after Docker. I find that's useful. And the steps for setting that up is I really just followed what was in this URL here. So you basically in Docker you pull down the Portainer image. You set up a volume for the Portainer to hold the data that's going to be kept between instances, and then I use this command to set up Portainer. Just a note here, I'm using Pi AI as the name or the host name for my Raspberry Pi, and then I'm using Jet AI for the Jetson Nano device. Once it's all installed, this is kind of what it looks like. I've got a few applications already installed on my machine. So finally I wanted to install Open-Webui on the Raspberry Pi, so that runs as a Docker application or a Docker container. This is the command I use to run it. Again, if you go out to the Open-Webui website, their Git repository will tell you how to format this command. The main thing to notice here is I use the port mapping, so internally Open-Webui talks on 8080, so I changed it to 3000, so it's got a fairly unique port I can connect to. And this other option here, I set the environment variable of Ollama base URL to http://jet AI, so that's the Jetson Nano host name, colon, and this is the address of the Ollama API. We saw it in the previously when we were setting up Ollama 11.434. So that runs Open-Webui as a container, and then I can connect to it. So this is what the web interface looks like for Open-Webui. So it's connected into my Jet AI LLM. It can see what models I've got installed out there on the LLM. So these are all the models that I've got available. I'm going to use this one here, and then I can control how I chat to it. So you can do things like we did through the command line, just do a simple hi.
How can I assist you today?
So that all worked. It has other utilities like this little information bubble. It can tell me how many tokens per second I'm processing, which is useful. Some other things on here is there is a text to speech, so you just heard it there maybe, where it's speaking what the response was. There's also options here for under admin panel to do things like set the settings. I've used that for adjusting connections. So there's the connections we saw when we set up my Docker container, but I can also adjust it in here, what connections to LLMs I'm using. And again, remember I'm having this all built into the Jet AI server, so nothing goes out to the web. So that's why I'm setting up my connection to go to an internal LLM. The other things I've used is things like setting up documents to use for RAG. It makes it easier for doing things like that. Set up the audio options, what's voices you want to use, as well as a whole bunch of other things here. So it makes it easy to look after your LLM. In the long run, I'm probably going to write a Python front end to my LLMs. I probably won't be using Open-Webui. Open-Webui is still a nice utility for doing quick chats and trying out prompts and things like that. Let's have a look at the hardware. So I used aluminium extrusions to make the rack. Came out as pretty solid, but I think if I did it again, I'd use one of these kits off Amazon for $80. It's about the same as the extrusions cost me. First panel down has the Nano Jetson and the 5-volt power supply. For mounting the Jetson, I found this STL file, and I'll put the link down in the description below for where you can get that. But printing that out was pretty easy, and it locks it down pretty well on the first panel. Then the next layer has the Raspberry Pi and the Ethernet switch. So it's 1 to 3 switch there. Also has a connector to connect my 5 volts to various devices on this layer. Then the top layer, I just put a I/O type panel in Perspex. It's got an Ethernet connections and fuse and switch. I connected all that together. The rack kind of looks like this when everything's connected up. Some of the other things I put in there was a graphics HDMI connection, so I can connect a panel in if I really want to for the Jetson. You see the wiring here, Ethernet coming in at the top, power supply going down, being split to 5 volts and then out to the Jetson, a fuse and a switch, and a USB-A connector for getting 5 volt power. So let's have a look at everything running. So what I've set up here, so I'm going to connect up to the Open-Webui interface. I'm actually going to do it through HTTPS. I've put a reverse proxy in between so I can use some of the audio stuff. Otherwise, the browser doesn't let you connect to your microphone and things unless you're in HTTPS mode. And then I've got 2 btop sessions running here. One on the Pi AI, so this is the Raspberry Pi. At the moment I haven't run anything on it. I've just done a startup, and so memory used is fairly low. And then same thing for the Jet AI So this is a Jetson Nano. Again, I haven't run anything on it, so memory usage is really just what the headless state uses in minimum state. Okay, so let's first fire up Open-Webui, going via the reverse proxy. Okay, so I've connected in through the reverse proxy. I've given it access to my microphone, so I can go into this voice mode, which is kind of nice. It's just like an audio chat interface.
The face is a fascinating and complex aspect of the human experience.
So what happened there, it just got the end of my whatever I spoke. You can see here on the Raspberry Pi, it did some processing, and now we're using 1.24 gig of memory because it actually brought Whisper into memory to do the voice to text, and it also loaded up our Llama 3.2 model on the Jetson Nano, so we see here. So let's try it again with some a reasonable question. Why is the sky blue?
The sky appears blue because of a phenomenon called Rayleigh scattering, named after the British physicist Lord Rayleigh, who first described.
How old is Mick Jagger?
Mick Jagger, the lead singer of the Rolling Stones, was born on July 26, 1943, which makes him currently 80 years old, as of July 2023.
So that's about it for the demo, but it shows you here why it's useful to have Open-Webui. I can also type things in through the text interface here. Also, you see here for the voice to text, the voice interface. That's happening on the Raspberry Pi by the look of it. You can see all the CPU activity and the memory bounced up when I first started doing that. And then you see down on the Jet AI, it's really staying fairly constant for CPU usage. It's really not using a lot of CPU for the questions I'm asking. And it's staying constant at the amount of memory used because I'm just staying in the same model. So that's about it for this video. Next one, I think I'll get more into the software. I also look to actually install this box in the Scamp. I think there's plenty of room under one of the seats. I can fit it under there without a problem and just connect 12 volts up to it. Probably use a fuse connection for that, so I have to work out how to do that. And then for the software side, I'm going to actually get more into using things like LangChain, RAG, MCP, and get that park and the Scamp information in as RAG information, so I can do more sort of intelligent and less hallucination oriented inquiries using my LLM. I'll just get most of the information out of RAG or the data provided through agentic calls through MCP. But more on that in the next video. Thanks for watching.